Hello, everyone. Welcome to AI Learning Series Session 3. I would like to say thank you to everyone who have been amazing in contributing and learning to this AI Learning Series. And I would really appreciate all your time, effort, and the effort that we are putting in this AI Learning Series, and you are benefiting from that. So today's session is Introduction to RAG and teaching AI to remember and retrieve. This session will be driven by Sonika today. So if you can go to the next slide, I'll just introduce you who we are, what WCC is all about. So Women Coding Community is a safe place for women and allies of women to thrive in tech through education, mentorship, and community building. We run lots of workshops and events like these. And I think one of the most successful program on WCC is a mentorship program. And if you are not part of it, or you have not enrolled in any of our ad hoc or long-term sessions before, you will get to have a chance probably next year now. But this has been a wonderful year for WCC. And this series, and if you would like to know more about our community, more programs that we run, you can scan this QR code, join Slack, or you can browse through the meetup that we keep on having lots of fun events and some amazing event that is going to happen tomorrow as well around career guidance. For code of conduct, you can go through the link that's provided on the slide. I can put in the chat as well. You can find it on our website as well. So if you have any concerns, anything to raise, just reach out to us. Next slide. So as I mentioned, today's session is going to be driven by Sonika, but this series is hosted by me and her. So we both are quite extensive experience in tech space, and it's all what we are presenting today is all we have learned in the past year or this year, and we continuously growing and learning as all of us in tech about AI. So if something you think is not at that level, or you have questions or discussions, feel free to answer in Slack, and we'll be happy to answer and start that conversation there as well. So over to you, Sonika.
Thanks, Sonali. Okay. So let's talk about the journey quickly. So we have done like 2 sessions already. I did the first one about LLM introduction, how to use LLMs for your use cases, some of the post sampling parameters, and some of the things which you need to know before you use those APIs and SDKs. And second session was prompt engineering from Sonali, where we learned about different techniques for prompting, the security, prompt injection security, and other stuff which goes with the prompts. Today, I'm going to talk about RAG. Agenda. Yeah, so today we'll talk about RAG. So if you haven't heard about RAG before, it's going to be like the external systems, external databases, which you can use to enhance your information which you want from the RAG, from LLMs. And then we'll talk about embeddings, which is like the base for any RAG system. Then where to store embeddings is vector databases, and then a short demo. It's going to be very interesting session. Let's talk about what we discussed earlier. So as I said, the first session was about how GenAI works. So now you have this prompt, it is tokenized, goes to, there is your context window, which is passed on to a transformer for inference or your foundation model. And then it will give you some answer, which is de-tokenized, and then there's your completion. These are the like keywords we used in that session. And we're going to work at the prompt level today. So it's another technique for similar to prompt engineering, but it makes it very domain specific, your answers from the LLM, or you can provide some information which is like private. So, okay. So why do we, so this is the question always, why do we need RAG? So, so I will talk about the full form in a bit. So RAG is like you using LLMs, but there are some problems with that. They hallucinate. There is a cutoff date. So for example, most of the LLMs which are available today have like cutoff date of 2024. So they wouldn't know what happened recently. So it's not current. And sometimes it has knowledge limitations because it's trained on general public knowledge from the internet. So whatever is publicly available, it doesn't know about your domain. It's not very domain specific. Or it's not, sometimes it doesn't know what is, it can't know what is your internal company policies or your internal some factors which you need to pass, which you can pass to the LLM and it will give you better answers. So these are the problems, and you can correct them with RAG at to some level. So this is like the first step. Let's see what is RAG basically. So this is the big picture. If you think about it, so RAG is like retrieval augmented generation. So the answer is in the name itself. So retrieval is like when you're asking RAG, so LLM something, you can pass some information which is very specific to your question. So for example, if you're asking, what is a holiday policy, and LLM doesn't know the holiday policy for your office or your workspace. So you can pass it a PDF, for example, and it will know what to find from that PDF based on your question. So it can, so you can retrieve the relevant document, pass it on to the LLM. So you're augmenting your LLM with some information which is for your use case. And then it'll generate a very specific answer to your use case. So basically you're giving it like an index to your library. And the keyword here is like, look it up before you answer. So you don't just start answering questions. You give it some, so your LLM will need some indexed information. And based on that, it will give you relevant answers. Any questions, anyone? Cool. Let's go to the next one. So this is the basic components in a RAG system. So there are like two parts. One is offline, one is online. So what happens is like, first you need to know what is your information system. So sometimes it's like PDF, sometimes some JSON documents, it could be images. You can have multimodal system these days, which can be passed on. So you can have your websites, internal websites. You can have your databases, which have your product catalogs. It can be your, so your last year's information, which is very specific to your company. So you can, so that is your first step to know what is your, where are your documents. And then you divide it into chunks. You, for example, if you have like a 500-page PDF, which is relevant to your question, you don't want to pass the whole thing. So you have to chunk it. This is the most technical part in RAG. Other than that, it's quite simple steps. Like it's just one extra step with the RAG, LLM call. So you have documents, you chunk it, then you create embeddings. We'll talk in a little bit what is embeddings. And then you save it in a database, which is called a vector database. This is optimized to store your information in numbers, which is like embeddings here. So you created this system, which is a vector database, and it has all your internal knowledge. And you can use this later on whenever you're making an LLM query. So when you question the LLM, which is your prompt, so it'll, first step it'll do is it won't start answering questions. What it does is it goes to the vector database and retrieve the relevant chunks, basically, and the documents, and it adds it to your question as a context, pass it on to the LLM. So your LLM will give you relevant answer, not something which is like made up or which is like a hallucination, if you know the word, which is where LLM is making up something which seems very true, but it isn't. So somebody raised a hand. Is it?
Yes,
Yeah.
thanks for the overview of the RAG system. I had a question. If you, how may I say, can you implement the RAG system on any LLM or any AI system, or do you need a specific tool or a specific software to implement the RAG system? For example, does it work only with ChatGPT or Gemini, or can you make it with every LLM you're creating with an API?
So yes, so here the relevant thing is, so if you're asking about the tech stack, you definitely need a vector database, which is optimized to save vectors. It's not a relational database. It's not a NoSQL database. It's a different kind of database, which is, we'll talk about the optimization. And then you have embedding. So you need to convert your document to numbers. And for that, you need LLM, which is for embeddings, basically. So it will be another call to the LLM. So for example, Gemini has embedding models. OpenAI has embedding model. Most of the major AI providers, LLM providers have embedding models.
So as long as it got the embeddings model, it is okay. And you have to make your vector database, but if it is, it's okay. Thanks.
Yes, so you'll write your code in that way. So you search in the vector database first, and then you ask the LLM to answer your questions.
Okay, thanks for answering.
Cool. The next one is, so there's another question. You wanna, okay, so.
Yes, me.
What are the challenges? We'll talk later about the challenges.
Okay.
In a bit.
Thank you.
And when we upload files to our LLM, yes, I'll talk about this as well a little bit. So, okay. So what is embedding? So this is like the most interesting topic I have found since I started learning AI or started using AI. So embeddings is, so if you haven't heard before, it's nothing. It's your token converted to a number. So internally also, most of the foundation model use this technique in a different way because they also save numbers. But it's like, it's made easier for us to use it for our own information. So for example, you have your PDF, they have some words. So words will be converted to a vector using the embedding models we just talked about. So it'll be converted to these vectors. So in a vector, in embedding form, cat and kitten will be like near to each other than a car and automobile. So although in traditional system, if you think about it, car and cat seems very similar, but in embedding, they'll be far apart. So there will be very different embeddings. So this is like 0.2, this is 0.9. So they will be close to each other, even if they sound similar or maybe similar. So basically, in embeddings, we get the context of the word, not just the words or the characters in that. So basically, if you say bug, that's the easiest way I have understood this. So if you say bug, it could be an insect. It could be bug in a code, or maybe somebody's bugging you. So they're like different contexts for the same word. So all these, so when you save this word to a vector form, your embedding model will take care of the meaning of the word, then the word itself. So it's like it will also take care of what is closer in that sentence to that word rather than just that word. So if it makes sense. Sentiment. Yeah, that's right, Denise. Cool. So what we do is we have this data. Data could be anything. As I talked about, your websites, your PDFs, your databases. You have embedding models these days where you don't even have to differentiate between what kind of input you are giving it. Your embedding models are multimodal these days, which means if you have an image which has cat as a picture and cat as a text, it will create embeddings for both of those. So it can take care of multimodal stuff. So audio, video, images, and text in itself, and converts to this embeddings. and it stores it to a vector database. Now let's look at the dimensions. This is the easiest way to understand this. If you think of dimensions, so in generally, like in our life, we look at like 3 dimensions at the most, 4 if you take sensations or whatever. But in case of embeddings, some of the models have, I think, 1536 dimensions. And most of them have at least, I think, 768. So that's what I worked with recently. So if you think about it, even in 3D space, there is so much information you can save. Imagine the scope of data or meaning or semantics you can save in 1536 dimensions. So for example, in this diagram, you can say women and queen are near to each other, maybe in the same plane. Women and girl also in the same plane. Girl and princess are near. But girl and boy are in different space. But in terms of, like, they're both young, so they are in another space, they are close to each other. Then you have man and women at the same side, but they are different from gender dimension. They are very distance from each other. And then you have man and king, and then boy. And so this is like 3D at the moment. So you're taking 3 dimensions. So you're taking gender, you're taking age, and you're taking maybe designation. So queen, king, prince, princess. So they are like 3 dimensions here, which is like, this is the max we think of when we think of something. So we think in maybe 10 dimensions. We can't think of more than that. But your embedding model will take care of so many things, so many contexts. And this is kind of hidden to us. So they are like embedding models, but what dimensions they have, it's hidden to us. So they don't tell us like how they create embeddings. Okay, so now you have all of this, and you will think about it. So if you have like 1536 dimensions, and you have thousands and thousands of documents, how do you search in it? So that's where there are some algorithms which comes into picture. So this one shows the nearest neighbor search. This is like the most common one, and it's like approximate nearest neighbor search. So if you, so what happens is like you made this query to LLM. That query is converted to a query vector. And the important thing to notice here is you need to use the same LLM embedding model you use to create your document to do this vector as well. So same one. So if you use a different one, it will have different dimensions and everything, so it won't work. So you have to use the same model you created your embeddings with, and then it will figure out, okay, so this red thing is my query. It doesn't lie in sports document dimension. It doesn't lie in finance document dimension, but it's near to technology. So this might be the nearest one. So it figure out the nearest neighbors, and from there it will like, there is lots of advanced techniques to figure out what is the answer. So maybe we'll take like top 10 chunks which are similar and pass all of the 10 to the LLM as a context. Any questions here? Pretty simple, is it? All right. So now, as I told you, so the next part is chunking, which is the most technical part in that, because otherwise it's just one extra call to the LLM to get the embedding vector for your query and then searching it. But as I said, your document is like huge, so you need to create chunks. Now, the question is how you will create the chunks. So there are like multiple techniques to create the chunks. So how do you decide how many top results to pass to?
I think she froze.
By tokenizing.
I think let's give few minutes. I think something went wrong. You might be rejoining. Give her a couple of more minutes because, yeah, I think she should be back. Yeah. You are on mute. So yeah.
Sorry, there was some interruption. I'm just going to share my screen. Okay. Sorry about that. Okay, let's carry on. So we are at document chunking. So so we'll talk about some of the techniques with the document chunks,
There is
how to create.
There's a question that we were discussing. So there was a question in the chat.
Yeah.
So in practice, how do you decide how many top results, like top 5 or top 10, to pass to the LLM for the best answer quality?
Yeah, I think I was answering that when I went offline. Yes. So basically, it depends on your use case. So what we do is when we create a RAG system, and when we're testing it, at that point, we need to understand how much information we need to pass. So sometimes if your documents are like very precise, so even one chunk is enough to pass on. And sometimes if your question needs like 5 different results, you want to pass at least 5 chunks so it knows at least some information to look into. So that way it will, so basically it's a very use case specific stuff. So maybe it also depends how you chunked your documents. So, okay. Let's look at the strategy. So the first one is fixed size chunking. So fixed size will be like you have a document and you say, now here fixed size doesn't mean your words or your character length. Fixed size here is like tokens. You know, we remember tokens from the first session. So everything from your query, your prompt will be converted to tokens. So your chunking strategy will be like you'll say, okay, let's fixed size will be like 200 tokens, one chunk. And there's always an overlap. So you have, for example, like one PDF with like 100 lines. So every 2 sentences will be chunks, one chunk. So there will be an overlap to maintain the context. So sometimes even if you're like talking about a single document, if you cut it into like sentences, sometimes single sentence doesn't make sense. So we have this overlap and it goes with every strategy you have for your chunking. So you always keep some. So like if you're having 200 tokens as a chunk, there'll be at least 50 tokens of overlap between two. So it has more context. So for example, if you search for something, it found a chunk for that. Because of the overlap, the minimum chunks it will find for your query will be 2. So because there's an overlap and there is some context overlapping in there. Okay. So that's the simplest one. So we never go with simplest if you want good answer. So let's look at the next one. So the next one is semantic chunking. And this is available in some of the ways you can chunk your. So the demo will be with LangChain. So it gives you different ways to do chunks. So in semantic chunking, what it does it automatically picks up some of the meaningful stuff together and then make chunks based on that. So it's talking, for example, in this information, it's talking about artificial intelligence. Then it switched to machine learning, which will be another chunk. Then deep learning, which will be another chunk. So based on semantics of the text, it will create different chunks. But here also, you will always have some kind of max length, because if it's talking about artificial intelligence for 1,000 lines, you don't want to create one chunk. So there will always be some recursion there, which will be our next strategy. So we are actually keeping the first one and overlapping it with a little complexity. So you still have your first one, which is the fixed size. So you still give it a size, and then you have semantics. And let's look at the next one. So this is recursive chunking. So how does it work? So we just talked about it. You have fixed length, you have semantic, then you also do this recursive one where you say, okay, 200 is my max. After that, you check if your chunk is bigger than 200. Then you divide your chunk into multiple parts, and you keep doing it until it's the size you want. So this is recursive. Okay, so let's look at the next one. Next one is also very commonly used, and here you can forget about the previous ones, because here what it does is it's very useful for like empty markdowns or for PDFs, which always have the same format. So sometimes you use like same structure of document for different customers or something. So you have these sections. So what it can do is it can chunk your document based on your section. You'll have different introduction, you'll have conclusion, so something like this. So it follows your structure of the document. Yes, you can. So there are some techniques I've used in the demo. So you can try it there if you want, Chris. Okay. Okay. So these are the like basic ones. And the last one is quite interesting. Why not use LLM to chunk? So decide your strategy. So you can pass your document to the LLM. It will tell you which strategy or what works better. And this, if you think about it, like you have to think of the cost here, because your LLM will be charging you a lot more for big documents or your whole database or whatever to tell you what are the meaningful chunks. Any questions till now for chunking strategies? Not that difficult, but it's just when you work with these, you will figure out that deciding on what works for you is quite. Yeah, Niharika, go ahead.
Yeah. So if, let's say, we do not use the LLM strategy and we go by the other strategies which you mentioned,
Yes.
how do we achieve those chunking? Essentially, do we have any like libraries kind of thing, or
yes,
how is it done?
Yes. So as I just mentioned, you don't do it. You can do it yourself from scratch if you want, but there are libraries available for these are like the basic strategies. So all these strategies are available in some of the libraries which I mentioned just now, like LangChain,
Okay.
QAI. There are the different ones. They give you these. So you just mention what type of So what type of chunks you want to make.
Yeah.
So it'll do it for you.
Yeah. Thanks for answering that.
Yes, thanks. Okay, so now you know what are embeddings, how they're used in RAG. So you created your chunks. Now, where do you save them? You save it to vector database. So here, this little screen shows you how they're like different from a traditional database. So in traditional databases, you will say, okay, the name is John, age is 25, or city or whatever. So you give exact information, you get exact data back. But in vector, this is all about probabilities and similarities with AI, right? So you don't want the exact answer. I mean, it will come at the top if there is an exact answer, but there are similar things which will also come up. For example, if you ask, so if you're looking for some sessions we did on Python in WCC, so you'll say, can you tell me if any beginner sessions from WCC on Python? So if you say beginner and Python, your similarity search will also bring sessions like starter level sessions, or something which is similar to that rather than just exact match. So it helps figuring out more data, basically. So it makes you more efficient in your queries. Okay, so this one gives an example of ChromaDB, which is an open source vector database. It can run locally, easy to deploy, very smooth, easy to learn with. Like I learned it in a day, so you can do it too. And then if you have enterprise level data, you want more security, you want better performance, you go with enterprise levels. For example, you have Vertex AI. It's cloud managed, it's scaled for faster search, better indexes in vectors, and it can save huge amount of embeddings. So basically, in your vector, you are not just doing keyword search, you're also doing semantic search. So similar stuff, not just the right match. So I just gave this example to you. These are some of the vector database landscape. As I said, ChromaDB we used for this demo. You can also go with some of the other ones. So these are dedicated vector database server. There are some which are like commercial. So I've used Pinecone, it's quite good. And then you have like other ones which are optimized later on just for vectors. So there are lots of other commercial servers coming up. And because RAG is like the base these days for even agents, so your agents will have to work with some kind of RAG, could be graph. There are like graph-based CAGs and everything, other systems as well, which are similar to RAG. So it cannot, so if you don't understand these concepts, can't use those, so you can't work with agent also these days. So it's very, because you have private information which you don't want to share with anybody, so you can use RAG at that point. Yeah. So this is the full flow. Let's talk about it the first way. So you have this 1 and 2 is your first phase, where you talk about the documents, which you are encoding using your embedding models. Then you're indexing it in a vector database. You don't need to understand how vector databases work, but there are like a couple of things. For example, when you save something to a vector database, you're not just saving your embeddings, you're also sometimes saving your original text, which will be retrieved as a chunk for you to be used in a prompt. And it also have metadata, which is very, very important, because so your metadata will have information like where your chunk was found for citations. So you want to know where your where this search brought you this chunk information from. So in your metadata, you can have either your website URLs, you can have your PDF names, anything you want to save. You can also like categorize it there. So, these are the resumes. So you can have a document type there. So resume, or your catalog or something like that. So your metadata is really important if you want to understand where your search similar documents of chunks are coming from. And then you have these similar so after the vector database, your actual query starts. So your prompt is encoded using the same embedding model. And then you will have a vector which will be searched in your vector database using all the algorithm which vector database has. And then it gives you some chunks back based on your use case. You decide how many chunks you want to use. You can pass all of those to your prompt because these days the context size is huge. So if you're not worried about the cost, you can use the whole context. And then you can pass it on to the LLM, so it gives you better responses, which are genuine. And you can use some prompt engineering techniques here. You say, if my context doesn't have this answer, just say so. Don't make up answers, something like that. So it'll give you the answers which you're looking for from your own data. Okay. Any questions for the process itself? Yes.
Hi, thank you. I just want to know, are you saying that for that prompting, like with the prompts number 6, does it mean that we can write a prompt to stop the AI from, the data or the RAG method from hallucination? Like, do not make up data if you can't find this data.
Yeah, you can do that. So you can mention it there that because when it's hallucinating, most of the smart reasoning models these days know that they're hallucinating, that they didn't find this information, they're making it up. So if you mention it in the prompt, this is, just use this context, don't go outside it. So imagine how important is your chunks here. So if you're giving irrelevant chunks and you're telling not to look anywhere else, so your answers will be relevant as well. So here, like there's some very important, so that's why chunking is very important to understand that it actually works for your use case, and then you pass it on to the LLM. Okay. Now so I will just talk about some of the some of the issues which you can have with this. We already talked about the chunk size. So your chunking need to be very specific. So for example, the general standard is that your chunks should have minimum 200 to maximum 500 tokens. So we shouldn't go beyond that because that way your chunks are like too big or too small. So it won't work properly. The second one is that you need to test your system to see if it works with your chunks. So if you are printing your chunks in your code, and check yourself that if you can answer the query you made using those chunks or not. So if you can't answer that, your LLM will also make up stuff then, even if you're saying it to just use this context. So that is the second thing. So they're like different problems you can have, but for now we'll just, because it's the foundation level, so we'll just talk about these things. So chunking strategy is important, how you do it, and the size of the chunk. So yeah, they're like advanced techniques where you also re-rank your chunks to get better answers. But for now, yeah, this is the process. Now I just wanted to show you quickly. I know we talked about this already. So we have your you have your prompt engineering. We talked about it. We talked about RAG today. So this is basically your context optimization. So in earlier times when context size was too small, so RAG was really important and prompt engineering was really important. So you get shorter answers, which fits your context. But these days you don't have that issue, but still to get relevant information, we use these techniques. And there is this fine tuning, which is changing the weights of your model, which is an advanced topic we might cover later on next year. But these are the basic ways to leverage your Gen AI. So now, which one to use and when? So let's quickly look at this one. So you can use all three. you can use 2 of these. So because fine tuning is expensive, so you can check these overlaps. It tells you, so you always go with, you never go with prompt engineering in any of the use cases. So you always optimize your prompt, and then you can apply your RAG for any external knowledge base you want to provide and up-to-date information. So you use any which works for you. All right, this is demo time now. Let me share you my screen. Okay. So there is a new folder in our repository today. You already have the link. If you don't have, Sonali, if you can share the link for a repository. So there is a README file. It tells you all the information you need to know. I'm not going to talk about the same stuff again, but you need an API key, definitely. And now, because we are using an embedding model, and for that also, you need to make sure whatever model you're using has embedding model as well available. So I'm using Gemini, which has both, so which is good for me. So so what it does is, I'm going to show you the Streamlit directly this time, so it's more visible results. So I think it's open here already. Okay. So this is the basic system, how it looks like. So so what I did was, in my code, if you see this folder, this is a live demo one. I used Chroma, as I said. So I created a local folder. So what it does is, it just create this database here for you locally, which you can also deploy later on if you want to. So this is like a SQLite database, and it has your embeddings. And this is a vector database optimized to give you results from embeddings. And then you have this demo. If you look at the libraries I'm using, so I'm using GenAI from Google, which is Gemini, and embedding Google embeddings. And I'm using ChromaDB as a vector database. And I'm using a text splitter from LangChain, which is a recursive one, because if you see my data, so I'm just providing some JSON blogs here. This is how we save in WCC platform as well, our blogs. So it's similar information. So I'm providing this as metadata, and the other stuff is chunked and saved as embeddings. So this is like one blog, and it's like an array of blogs here. So it's like sorry. So yeah, a few of these, okay, I can't. So I'm using this sample data as the input to the embedding model. And if you look at the code, I'm using text embedding. Now we have 5 as well, so you can use 5. And I think Gemini embeddings are also, it was released recently, so which is like even more optimized for more dimensions. So you can try that. And this is how you create your Chroma client. Nothing, I just gave a path where I want to save it. That's it. It's a persistent client. You create it once, and then you chunk your documents. Let's look at the chunking here. So I'm using recursive text split. You also you want to give it some separators, because one paragraph finished, it should automatically stop the chunk there. You don't want to have multiple paragraphs in one chunk. So some of these things you need to provide. You also provide your length, which is here it's 400 and overlap is 50, which is optimized one. And what it does, it offline first, it saves your embeddings. I already created those for that JSON I just showed you. And after that, it generates embedding. That's it. So after generating, that embedding will be converted to your actual text, which is the chunks. That will be added as a prompt, as a context to your prompt. And then we send the final prompt to your LLM. Okay, let's look at so this is using ChromaDB, as I said. You can also try Vertex AI Vector Search in your locally, so you can try it easily as well. But it's not free. Chroma is free. So what it does is, I'm gonna just show you. If I say, okay, so I'm doing a Python query. It's looking for answers. Hopefully it works. So this is showing me that it has indexed 5 blocks and it converted it to 41 chunks. This is the model used. And for LLM, I'm using Gemini Lite. What's happening? Let's see. In the console. Okay. I just started it, so it's a bit slow. Nice. Okay. There is some issue. Let's debug it. All right. I think I just need to log into my cloud. So now the process is same. You go to the repository, create a fork, and then try to use what is already there. I'm going to run Streamlit again as well. And once you can run what is already there, you can make changes to it. There are some use case guides there. Why is it asking again? Okay. Oh, I think I ran the cloud again.
Yeah.
I always do that. Okay. Cool. Hopefully it works. If it doesn't, I'll show you without Streamlit. So yeah, so there are some use case guides in the code here. So we just thought of some use cases which are like relevant to us. So this one is the blog one, which I did. You can pick up the events one or the mentorship one. So we have like different mentorship programs than other organizations. So you can add your PDFs or whatever, like from website, and create your own system. Let's try this again. Yeah, worked. Cool. All right. So now, if you think about it, so it gave me an answer. I asked it, okay, some Python topic. So because it has WCC as the context, okay, so it has 41 chunks which are relevant to some blogs which we did in our WCC. So it gives you these sources back. Okay, so it tells you, okay, this is now these are like made up URLs. They won't work, but you can try actual blogs and see if it works for you. So it just takes you to something which isn't there, but we have a blog in WCC. Pick up some blogs from there, and it should work for you. Now I added these 2 checkboxes here to show you the thing which is really, really important here, which is citations. Where did it get the chunk from? So when I say, okay, show me retrieved chunks and the similarity. So when I ask for the question again, now because I asked for the chunks, it's telling me that based on my query from those 41 chunks, it got these 5, because I think I set 5 as a max. So it tells you, so, okay, so if you look at this, it tells you the source was this. Okay, so that is the blog name. The similarity is this much. Okay, not that good. It's because it's like, it should be 0.9 or something. And then if you look at this one, this is better than the other one because I asked for Python. So it has Python in the name. Obviously, it's better. And then Python for beginners. It has even better score, right? So because that's what I asked. So it tells you the chunks, which is very, very important, as I said. So always look for your chunk and see if they're relevant. If it's not, that means your chunking strategy is not good enough. You iterate over it. Okay, I think that's it for the demo. So now, if you have any questions.
I think an amazing session. I thought I will never know how these tokens and chunks would ever work, but a really nice demo where you can actually view how this chunking worked. So really amazing.
Okay, I have a quote for you in the end, which I love actually. So we use LLMs and we thought, okay, this is the right way. It works so well, so it can do so many things on its own, But there is always a better way. So don't go with we have always done it this way. That's like the most dangerous phrase. This is my favorite quote, so I just wanted to show you here because it's very relevant to RAG. And there are some next steps. So these are some of the blogs I used to create these slides, and some of the libraries which you can use for chunking strategies and some vector databases here. All right, QA. So Irene is asking, can you suggest any good resources for more background reading? It's here, but these days, just go to open an LLM chat box and just ask what is RAG, or any question you have, or anything which you understood last time but didn't this time, or you want to link the knowledge together. So make it personalized learning. Just ask the LLM. Ask it to give you some diagrams. That works so well. Okay. Somebody's going for lunch. What time is it? All right. Okay.
In France, it is 9 p.m.
Nice.
In France, where I am, it's 9 p.m. So thank you for your explanations. It was very clear and very, very pleasant. You made clear something. I heard a little about RAG, but you made it very clear by detailing every step in the process. So thank you for that.
No worries. Thanks for joining.
Thanks. Have a nice day.
You too. Yeah, somebody raised a hand.
Hi, sorry, I'm quite confused about the ChromaDB. You mentioned that it's a traditional approach, and yeah, that's slide. You mentioned the traditional approach to the database system, and I'm wondering, can I use like the ChromaDB, because I've never interacted with it before, but can I use it like I will use Postgres or I will use MongoDB? Yes.
Yeah, that's actually a very good question, and I forgot to mention it. So these days, when you design systems, sometimes you need exact information as well, and you already have your databases. So why not use those? So in case there are ways where you can convert your query, your prompt, to a query for your own database, then use that, definitely, and add that information to your prompt, and it'll give you better answers. But this RAG is basically designed for systems which are not indexed, and it works. So because, as I said, embedding can have like huge amount of floating point numbers, right? So it doesn't work well with existing traditional databases. So it'll be lost. So basically, it has some algorithms inherently in the database itself, the vector databases, which can search in quickly between those numbers. In real project, how do you balance between retrieval accuracy and the cost? Cost of processing large contexts. As I said, like these days, most of your LLMs have huge contexts. So but you still don't want to use the whole context, because as we talked in that first session, that big context doesn't mean better answers. So you need to, that's why we chunk these in a better way. So you can like pass 100 chunks. It still won't be like, it won't be covering your context, but it might not give you good answers because it's lost between all those chunks. So as I said, you just need to optimize for it. So this AI systems are not hard to build, they are hard to optimize. So they are harder to get what you want exactly from that. So that is where the expertise come into picture. Somebody raised a hand. Go ahead.
Yeah, it's me.
Yes.
Hi, Sonika.
Hi.
Very nice explanation. I really learned a lot. Thanks. I have a questions. Since, correct me if I'm wrong, since during your explanation, seems like the chunking strategy will, will affect how good the answer will be. Do you know, any strategy how to first measure what a good answer is? I know sometimes when at least currently right now, when working with LLM, I measure it qualitatively. I don't have any kind of metrics to quantify what is the good answer it is. And the second, if I want to version my chunking strategy, do you know any good libraries this chunking strategy will deliver this kind of result, and then the chunking strategy version 2 will deliver this result with certain kinds of certain amounts of successful answer, something like that.
So you have two questions. So the second one is easy to answer. So you have these libraries. So these are if you see on the screen, so LangChain, CryoAI, AutoGen. So these are they're AI agent libraries. So they're optimized for some of these tasks. So don't try to write it from scratch. Use some of these libraries. And this is just an example. There are hundreds of them right now. And even all the enterprise RAG systems these days, the vector databases at enterprise level, for example, Postgres has their own vector database. So they have their, so you have libraries which can use so create your chunks. So you use those and see which one works for you. I think LangChain covers most of it. So if you want to try first. And the other answer, so based on, do you work in QA? So it looks like a quality assurance answer, because that's what QAs ask us. Is it a good answer? We don't know. So in that sense, so yes, you definitely need to know if your answer is good enough. And I don't think I can tell you what is a good answer for you. But if you are looking for, so if you're talking about something like, we gave an example about company policy for holidays. And if it's not giving you an answer, you would know, looking at your document, that this is not the correct answer. If it's looking for certain price from your catalog, you will know this is not the right price. But if you're talking about something like documentation, so there is never a right answer. But I think it depends on your use case.
I see.
So
actually,
you can't say perfect answers. So
may I ask further question?
Sure.
Okay. Actually, what I want to know is that when we are building rack system, we are doing a lot of iterations, right? And during that iterations, if we want to, record each version of each iteration, which one delivers which combination of chunking strategy, and then prompt, and then document that deliver our certain result. Is there any libraries or any tools to do that?
So I haven't used any comparison systems, but there will be definitely some A/B testing libraries available. So we can look for you. Definitely. Yeah. Especially, I think the vector databases and all, which are the Vertex AI Vector Search, and which are enterprise system, they definitely have some of these libraries already available. But for us, for starters, I think we can look for some if you want to. So you can compare answers.
Okay. Thank you.
Always. Thanks. Anyone else? I want to see more folks on the repo, so please do that, whoever is staying back. And you want to see more code from you. And that is the whole purpose of this task, so these talks. So please try hands-on. If you have any issues, we'll try to resolve it with you. And as I said, I sometimes have some time on Friday evening. So just message us and we can do one-to-one as well. Okay. I think that's it. Did I? I think.
Yeah, I think
Was
we
to
can
be
wrap.
here. Yes. Yeah. Over to you, Sonali.
Yeah, I think that was a great session, and we got to know a lot about RAG, and I also learned so much. So next topic in the next session, we are going to talk about AI agents. So don't worry, I'll try to cover up from the basics what are AI agents, and we'll try to build a single agent. And then then post that we will have a couple of more sessions, and we will be wrapping up this introductory series, part 1. So if you have any questions by then, as Sonika already mentioned, just shout out, mention, talk us on Slack. And thank you so much, everyone, for joining.
Thank you. There's a QR code for feedback if you did like it or you liked it a lot. So thank you, everyone.
Thank you. Bye-bye.